What's going on, everybody? Good morning to y'all on the left coast here, and hello, I don't know, happy coffee or maybe tea or afternoon snack to a lot of other folks. Because having to explain something that you think is clever means it's not clever, let me explain the title of this talk. So in programming, the idea of working closer to the metal means working with languages like assembly or C that can directly manipulate the physical hardware. And then there's physical computing, whipping up breadboards and whatnot, which is something that we do in San Diego for prototypes of our interactive experiences. You're soldering leads, you're interacting with physical metal. And that's something like, Cameron Perry and Matt Morey, who used to design circuit conductors or semiconductors in a previous life, or Daniel Holstein, or Eric Parr, or Stash Noga, or Alex Olivier, all San Diegan folk. Something that they know really well. Legend has it, Alex Olivier, who's a new mom, shout out Alex. Legend has it that she used to walk around with a soldering iron in her fanny pack. So it don't get more legit than that. And then the third meaning for closer to the metal, I couldn't really resist the obvious pun. I'm John. Hey, I'm the Vice President of Operations and Delivery for San Diego. Today, you're going to be treated to a talk on electronic circuit building, kind of, by someone who never studied electronics or engineering. I mean, I did start my career as a developer, but I haven't written production code in over a decade. So basically, I'm a liberal arts major. This is gonna go great. This talk is gonna have a little personal background story to it, and some history, and some electronics talk, and some noise. Okay, so where do we start? Let's start with why. Last year, this little bastard rolled into town, which, as we all know, meant finding ways to entertain ourselves safely. I'm a guitar player, so I played more, went deeper into music theory. I took Skype lessons from some of my favorite players to kind of help support them while they couldn't tour or do shows, and basically hunkered down. And along with hunkering down came the probably familiar urge to sort of self-comfort amid the uncertainty. For some folks, self-comfort came through food or through booze or through whatever made them feel better. For me, I kind of found myself jonesing for equipment. And you guys might be familiar with the sort of aspirational shopping where you get it in your head that this thing, whatever it is, will make you better at something or get you to the next level or in some way enable you to accomplish more. For guitar players, this is called gear acquisition syndrome, and it can be pretty acute. There's so many products out there, and there's so many variations. And then within the products, there's this real or perceived level of quality. And then there's how the gear represents how we see ourselves as players and correspondingly what we feel we deserve. But I mean, I'm not going to a guitar store in the middle of a pandemic, and handling a bunch of things that other people have had their hands on just to test drive equipment. You got to remember that guitars are predominantly made of wood. They're by and large made of biological materials. And so that means they vary quite a bit, from model to model, but also different guitars of the same model from the same manufacturer will be different. So ideally, when you're in the market for a guitar and you're jonesing or you have gear acquisition syndrome, you go to a guitar store, a guitar shop of some kind, and you go and try a bunch of instruments and see what speaks to you. But this was obviously a no-go for me during the pandemic, particularly when it was uncertain how big a deal fomites were as far as a transmission vector. So what's a boy to do? Well, I zoomed in on effects pedals. And what is an effects pedal? Well, it's basically an electronic device that goes between the guitar and the amplifier and adds an effect of some kind, like phase shifting or fuzz or distortion or echo, or somebody waiting in the lobby, all sorts of stuff. And they do things that neither the guitar nor the amplifier can do on their own. So with YouTube in hand, I watched a lot of demo videos for a lot of pedals. And there's really no shortage of these suckers on the market. It's been kind of a booming boutique industry, and then there's some large makers. But there's a couple problems. These things are pretty expensive. They're like $150 to $300 or more each. And they aren't really necessary. They don't make you, a better musician. Sure, they can add a color to your palette or enable you to recreate a sound from a song or from your favorite player. But, where is that taking you? And finally, ultimately, I'm self-aware enough to know that I'm jonesing for gear as like a self-comforting thing. But, they're fun to play with. And as it turns out, they're actually something you can build on your own and like at a fraction of the price. $150 or $300 becomes maybe $30 to $60. It just takes some time and effort and figuring out how it all works. And given COVID, I had the time, and it seemed like the perfect hobby to dive into. So guitars and pedals and electronics, how does this all fit together? So let's go back some years to dig in. In the early 1820s, some people, Hans Christian Ørsted, figured out that electric currents create magnetic fields. That's cool. And William Sturgeon, that by winding a piece of iron with wire in a whole bunch of winds, and then running a current through the wire, you can make an electromagnet. Faraday thought this was cool and figured out that if you take a coil of wire and pass a magnet, like a pole magnet, a straight magnet through it, it would generate an electric current. So this is electromagnetic induction. And Faraday also made a whole bunch of contributions to all sorts of stuff, like capacitors and different electronic components that, I'll sort of touch on later. And then, science tromped on. From the late 1800s into the 1900s, radio technology advanced to the point that it became accessible and popular enough to be in most U.S. houses by the mid 30s. And a lot of the same components. And I mean, this schematic is old, but you could ostensibly build this. A lot of the same components and things like resistors and capacitors are present in this technology as they are now. So, okay. We've talked about electromagnetism and the beginning of consumer electronics, but why is electric guitar a thing? Why didn't electric tuba take off or electric bassoon? This is Gina Gleason, by the way. She is a monster. She's one of the players that I got lessons from during COVID. Very cool lady. She's got chops. So along with radio and dance band, along with the radio, dance bands and big band jazz were also really popular in the 30s and 40s. And if you've ever heard a big band in person, you'll know that they are freaking loud. And a guitar was frequently part of an ensemble, but the acoustic guitars at the time were just not loud enough to be heard over the rest of the band. And so, they couldn't become a featured instrument or play solos and do that kind of stuff. So they were relegated to being a rhythmic background element, just comping chords in the background and sort of adding a percussive quality too. But what else happened in the 30s and 40s? War. And along with war came great advancements in electronics. So if we step back and talk about guitars, these are acoustic guitars. And on your left is a Spanish guitar or a classical guitar, which has nylon strings. And in the middle, beautiful archtop guitar, that's an acoustic guitar, and it has steel strings. And then the flat top guitar, which is what we associate with, an acoustic guitar now. And that also has steel strings. Going back to Faraday's discovery, if you take a pole magnet and you wrap it in coils of wire, like the sort of copper colored thing here, and you can see the pole orientation of the magnet, and then you interrupt that magnetic field with a guitar string, you get an alternating current through that wire. A steel guitar string, I should clarify. And that alternating current is carrying two important bits of data. Volume, which is the signal amplitude or the maximal and minimal voltage values, and then pitch, which is conveyed through the frequency of the alternating current. You take 6 of those pole magnets and you wrap them all in like thousands of winds of this very, very fine copper wire, and you space them out so they sit right under guitar strings. You got yourself a pickup and you have yourself an electric guitar, and you plug that sucker into an amplifier and it, amplifies the signal. This was revolutionary for jazz and for blues and also country music. And all of these things melded into rock and roll in the 50s, and it got loud. And the thing is, those early amplifiers weren't really great at handling loud volumes. You know, they were attempting to create circuits that would faithfully amplify or, you know, show the timbre of the instrument. But if you push the amp, at some point it started to distort. Folks like Link Wray latched onto that sound. And as much as he looks sort of like a milk commercial, his song Rumble is actually pretty darn gnarly. I would recommend you check it out. It's sort of like the earliest grandfather of metal. That dirty, distorted, noisy sound of an overdriven amp brought something entirely new to the party. And, you know, we have folks like the Kinks who, you know, the story goes, they took razors to their speaker cones to emphasize the distorted sound on songs like All Day and All the Night. And in this period, frankly, you know, the electric guitar departed from being a faithful recreation of acoustic guitar timbre into something entirely new. So manufacturers realized that something was going on and looked to make products to extend the range of sounds an electric guitar could produce. So the earliest effect is a tremolo. And yeah, this came out in the 40s, but I mean, don't ruin my narrative. Big Bill Broonzy, the blues player that I was showing earlier in the upper right, he was one of the first guitarists to be recorded on using this effect. And so basically, that's the tremolo effect. You see here, you know, the depth that the dip in the sound is, which would be the increased knob on this model, and then the speed that it's making that sound. And some of you UK folk or older people might recognize. You know, because you got to have the Smiths in your talk. Another desirable effect that folks wanted to have in their arsenal and that they started making was echo. And the technology didn't exist at the time to be able to essentially sample or capture sound as it's being played and then play it back electronically in circuits, I guess I should say. So these early models like this Echo Rec and some other designs at the time, under the hood, basically there is a reel-to-reel type magnetic tape. And so as you play, the tape passes through a recording head, just like, well, I mean, I don't know how many of you remember cassette tapes, but same sort of idea. It passes through the recording head and records what you're playing, and then hits a series of playheads, just like as if a cassette player had a series of playheads. And so it's your initial signal getting recorded and then being played back and then played back and played back. These things, obviously, it has its own briefcase, you know, not exactly small, but, you know, you get the idea. And Echo, you get the idea. That sort of thing. And I'm not just humming. This is the guitar. Another device, which hilariously, another device was the fuzz pedal, which apparently was designed to emulate the sound of horn parts. And it was profoundly unpopular when it first came out, because people were like, yeah, we can get a horn section. And it just sounded maybe not great until Keith Richards did that, I guess, while on another channel, pharmacologically, and it turned out to be incredibly popular after that song became a hit. And fuzz is something that really took off in a lot of different ways, and is really one of the most simple circuits you can make. And then, you know, a couple more things I'm going to talk about. So, something like the Univibe was an effect that was designed to emulate the rotating speakers that some organs at the time could do. The rotating Leslie speaker. If you ever get to see these things, they're literally speaker cabinets that have multiple speakers going around along it's like a Ferris wheel for speakers, which creates an interesting sort of Doppler effect. But those things are heavy and not very practical to go lugging around. And then obviously there's mechanical failure that can happen. So then somebody created Univibe, which creates that sort of chewy sound, which would be like a yeah. And of course, another popular one is the wah-wah pedal. And what this does is it's unique here. You can see it has a treadle, and you step on that pedal, and basically it is adjusting a potentiometer in there, which will, I think it's a potentiometer. Yeah, it must be. That adjusts basically, it's sort of like a parametric EQ, but focusing on a very thin band and emphasizing it. So you get so playing around with the treadle, you can sort of emphasize different things. And these things are modular. So it's not like you can just plug into a fuzz or you can just plug into a wah-wah. What you can do is link them together, not with dot notation because that's programming, but with just the little cables in between. And, depending on the order and things you place them, you get different results. And so when in this combination, for example, something like morning. I never said I was a good guitar player, but so stitching them all together was something that players were doing, but I would say that nobody really did what Jimi Hendrix did. And he really set the whole thing off and expanded the entire palette of what people could hear, expected to hear, and what a guitar player could try to do. And the last effect I would talk about is the phaser, which is really similar in a lot of ways to the Univibe that I mentioned before. But it's basically taking it's taking your initial signal and duplicating it. And then with different timing in between those signals, you get stuff like comb filtering and different interference between the waves. And you get that sort of thing, which is like a something like that. Clickety click. So anyway, electronics. So that's the run up to the roots of effects pedals and kind of where we are now. And a lot of the technology talks, or the different talks you guys been watching and joining, are really around cutting edge technology or applying modern technology to business. And I'm not talking about anything at all practical, really. I'm really just talking about curiosity and exploration and really getting into things and seeing how they work and why and enjoying it. And frankly, I'm also talking about old technology. This is pretty much considered mature technology. The same components and designs and those things that we saw earlier, I mean, they've been around for decades. So say compared to machine learning, what I've been learning is really kind of akin to film photography or maybe extraordinarily nerdy blacksmithing. And yeah, while effects pedals definitely have stepped into the digital world, right now I'm just kind of enjoying building stuff with my hands and soldering irons and just doing it that way. I think if you look at electronics knowledge on a continuum, there's sticking a fork into the outlet, and then there's knowing enough to not stick a fork into the outlet, and then going and buying kits that are pre-made and put together and assembling them from there. And then it's really understanding after that, it's understanding the schematics and how designs work and how the flow works. And from there, it's breadboarding those schematics out with all the components and getting a handle on how people's designs work and fiddling with stuff and trying some of your own stuff. And then after that, the wizard wand there is really, to me, like inventing your own brand new designs and ideas and trying stuff out. And I'm about right here. Pretty early days in the grand scheme of things. For me, I wanted to get into this, for the reasons I stated, and I wanted to do the most simple build humanly possible, and that happens to be a fuzz pedal. And so, I went to, I'll share links later, but I went to one of the places that sell the PCBs, the printed circuit boards at the bottom, but then they will also sell the entire kits, which come with everything you need. So this fuzz pedal has an extremely straightforward schematic and a very low parts count, so that check the boxes. And the funny thing is, when you buy a kit, at least the ones I bought, you really don't get much explanation. They kind of assume an awful lot, which is great, because then you have to kind of go and study and figure out how things work to sort of get to the level of being able to do them in the first place. You basically get, here's your enclosure, and here's your PCB, and here's a bag of parts, and the parts are not labeled. And so you have to go do the whole thing. With resistors, they have color stripes on them, and it's a laugh riot. And you get some wire and potentiometers, which is the knob thing, which is kind of a different kind of resistor, and then whatever integrated chip or chips there might be. And on the PCB is where you see the where the different things go. So R1, R2, C3, C5, that's where your capacitor and resistors go. And you just sort of paint by numbers it together. So with my old ass eyes and my soldering gun that had a tip that was way too big to be working on tiny electronics, I spent the better part of a Sunday afternoon putting this thing together. And knowing the folks in San Diego know this stuff, I just sort of solicited some feedback, and I got some really good advice. My solders here are pretty gnarly and a lot of things to touch up. And it worked right out of the gate, but it was a little noisy. But when I passed back through and reflowed, it worked like a charm. And so then that was my first pedal, which is this single knob fuzz. And yeah, it's supposed to sound like that. That is a fuzz. One of the main things it does is it takes your signal and amplifies it, but then it also just clips off the peaks and creates almost sort of like a square wave sound, which is that hyper distorted, gnarly sound. So pleased as punch, I built another fuzz that was just a little bit more complicated because, who doesn't like fuzz? And it's a slightly different, it has different choices and things. The other one was a one knob fuzz. This sucker, I'm not going to twiddle knobs here, but that's the general idea of this one. Again, more parts. You can see my workstation here. My third kit I built is an effect I really like. It's this auto wah. We talked about the wah wah pedal before and how you work the treadle to make different things. Well, this sucker basically makes that wah effect depending on how hard you strike the strings. And yeah, I like the wah effect, and that's fun. You can have fun with it. But for me, the really interesting thing about the envelope filter is not so much the effect that you just heard, but the fact that in there is electronics that are sensing the envelope of the signal and then doing something with it. And to visualize that, this waveform is basically, this is say the signal that's coming through, and the red line at the top is the envelope. That's the upper envelope. There's a lower envelope as well. And so sensing the value of that red line and using that to then impose a different effect, to me, would be really neat to play with. There are manufacturers that, really kind of boutique makers that do pedals like this, but there's not really that many. I'm not exactly sure why. Maybe it's not necessarily a popular thing and I'm just kind of weird. But, instead of using the knobs on these pedals to adjust the effect or the treadle, Imagine how cool it would be to be able to play something and depending on your touch, have it impose the effect, whatever effect on it, a fuzz, an echo, branch off the signal and somehow tweak it. So I don't know. That's kind of like where I'm heading. The electronics for that is well beyond my understanding right now. And there is some complications in building an envelope filter or an envelope follower. But that's where I would like to get. And so for me, the next step was after, all right, cool. I'm going to build these kits. I'm going to get comfortable with it. I'm going to learn a lot about diodes and capacitors and resistors and all that stuff, solder some stuff together. The next step to me is, okay, great. How about I start breadboarding out some schematics? And basically, well, I'll show you in the next slide, but a breadboard is a circuit board that doesn't really have any patterns in it, like pre-made designs. So the top and bottom gutters, you can see the plus and minus signs. Those are your power strips, basically. So that you would include a battery, you would connect a battery onto that. And then all the different vertical rows in there, they're all independent from each other, but they're connected vertically. So, you can see 1 and 1A is on the same channel as 1E. And so you can do different connections and basically build out your stuff from there. And one important thing is that a schematic is an explanation or a visualization of what the electrical design is, but it's not a physical design. It doesn't describe a layout. So the layout is up to you. And so for me, the next step after building kits and doing that kind of stuff seemed to be, all right, well, get a handle on how schematics work and how these different things work and what they're doing in there, but also get a handle on how to lay that out in a layout on a breadboard. And then once you have a breadboard together, then you can start fiddling and saying like, okay, cool. Like I appreciate that in this design, these guys are in some way modifying the signal. What they're likely doing and is basically creating filters on the frequency range that's coming through the pedal, so that we don't have maybe all the lows or ear-piercing highs. They're sort of taking out like the middle happy chunk that you want to manipulate. Okay, great. So that's what the design is doing. And why don't I, what happens if we put different values in here? What happens if we make them variable? Those kinds of things. These diodes in here, or this triangle is the integrated circuit or integrated chip, I should say. And so a lot of these schematics are, setting up your power supply and getting it in a good place to then be handled, be treated by the IC in there to do things or to pass through the diodes and create, that sort of blocked off the top sound, chop sound that I was describing earlier. So what I ended up with after, I don't know, a couple days of fiddling, but this is a rat pedal that I'm very familiar with the circuit. It's something that it was the first pedal I bought back in like 1990. Yeah. And so this is the guts of it, and this is how it works. And did somebody say something? Maybe that was just the coffee. So anyway, I guess I could try and fiddle with this. I have this sucker right here. But when it's on a breadboard, it's a little bit more delicate to move around and adjust things and stuff. But yeah, and so that was a great learning experience. And the next thing I'm looking to do is build out something that is starting to use that envelope follower that I mentioned, and try to get a handle on exactly what that's doing. Because to me, my amplifier does distortion, and I have fuzz pedals, and I have a phaser, and I have, a tremolo, and I have all these different things. But I would really like that, something really novel. And if it's not on the market, or if it's on the market and costs $500, may as well make it yourself. So I talked a whole lot about and am interested in really just the audio and the guitar pedal circuit aspect of this, but I'm talking about such a narrow slice of what you can do in building circuits. And frankly, it's probably not even that interesting to any of you. I don't think guitar is as popular as it was in 2021, as it was in, say, 1985. But there's so much you can do. You can do other audio things if you're an audio person. Modular synths and DIY synths is a huge thing. Building Euro rack modules that you can basically assemble a control panel for doing audio stuff. It's totally stuff that you can spin up yourself. And then way beyond audio, there's a billion things you can do with circuits and building electronics. I mostly stayed away from work stuff, but I mean, check out the things that the San Diego office did for Under Armour back in the day, where I loved going back into our back office and seeing, some of the breadboarding things that Alex and Eric and different folks had in the works, and Cameron, and the interaction between the physical stuff and handing it off to digital and doing things like this, the shoe sensor, and all the things you can do with an Arduino or Raspberry Pis even, or all that stuff. So, my little slice of the nerd world is very narrow, but there's just so much stuff you can do. And, we might have time right now to explore those things. So it's a good time to do it. On here, I have a whole bunch of links to different places. If you're curious about, guitar pedals in specific, there's, Pedal PCB and all these different places where you can buy pre-made things or printed circuit boards. There is Electro Smash and some different forums, Coda Effects, that really talk through how all these things work, which is pretty fascinating to me. And then within there's forums where people are digging in. Somebody will buy a pedal and then they'll open it up and do an analysis of that, do a schematic, and poof, it becomes the kind of thing that if you like, you can build it yourself. And then, of course, parts and components, which is a whole other thing I discovered, buying components and parts. One major downside, I will say, is I bought a whole bunch of components from Mouser, and it came, all the different items, all the different components came in individual plastic bags. And that gave me a sad, because I don't really want more plastic bags in my life. So I'm trying to figure out a way around that, and if there's ways to order them without getting that stuff. So, but that's another side thing. So anyway, Efkaristo, as they say in Greece, thank you very much.